Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. So, what is today's topics? Today's topics is very important topics on concrete. So, concrete is a homogeneous paste and it has aggregate, water, cement, and the admixture and also supplementary cementitious material. But the aggregate we will discuss today about the aggregate size. Why the maximum size of aggregates measure or why it is depend on the concrete performance. So if the maximum size of aggregates is changing, what will happen? The concrete performance will change. So how it is impacted the concrete performance? Today I will discuss each and everything all about the how the maximum size of aggregates impacted concrete performance. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's jump into the subject, that the aggregate size and concrete strength and durability. Now, all we know, the concrete is a homogeneous paste. It has water, it has fine aggregate, coarse aggregate, cement, admixture, and sometimes and the supplementarious cementitious material. But today I'm discussing about the aggregate size. Now there are different types of size of aggregate: 6.5 mm, 10 mm, 20 mm, 40 mm, 80 mm. So how this maximum size of aggregate is impacted on the concrete performance, that I will discuss today. So before that, we need to know the why aggregates is important. Now, aggregate has a major role in the concrete. To know the why aggregate is important, then we can find out why aggregate size is also important. So first thing is give the structural strength and the durability, because always check the what is the strength or the loss of general abrasion value, what is the crushing strength, that all we are checking before selecting the strength. So it has impacted on the structural strength and the durability. Now then it has the volume stability and the shrinkage control. Now all we know, the when the cement start reacting with the water, its volume shrink, so the cracks is generating only, that is called the shrinkage cracks. But this aggregate is help this volume stability and is control the shrinkage cracks also. And it is the economic and the cost reduction. So it's available in the natural source, it's the economical, and it's the cost reduction, and it's improved the workability, and it gives the thermal stability during the heat of hydration or in the what cement and water start reacting. And it is a durability and it has the wear resistance. Why? During the weathering or during the traffic, the it can be wear resistance is required, otherwise it will deteriorate the concrete of the surface. So the aggregate has the durability and the wear resistance property. So here you can check, these are all the properties we need in the concrete. So that is why if anything is missing, our concrete performance will be a problem. So that is why aggregate is important, very much important. Now there are different size of aggregate. Now we want to discuss how the size of the aggregates can be generating or can be impacted concrete performance. See, the higher the size of the aggregate is the lower surface area. Okay, these are the, so if the surface area is lower, that means the water will be consumption will be less. In the before it was thinking that the if the surface is the higher the lower size, lower the surface area and the water demand is less, so the concrete performance will be better. But later it was discussed, the already described, or it is found that it is not that one. But this has the criteria that we have to think whenever we are selecting the maximum size of the aggregate. So higher the size, lower the surface area, lower the water demand. And the air content, see, all we know that the air content is also a problem for the concrete, because in the air, in the whatever the intermolecular space or in the in between two particles, there is air voids. Now if the air voids present inside the concrete, it will be a problem for us, because this air pocket will not make a not will not make an homogeneous paste. And what will happen, there will be a void, there will be honeycomb, and the structural strength and durability will be the problem. So air content is also a problem, and it varies depending upon the size. It's not the same for all types of aggregates. So size of aggregates is also vary the wear content. The moisture content, if the surface area is more, the absorption of the moisture will be more, and the water demand or the water release whenever it will be in the concrete will be more. And then water requirement, the lower the surface area is lower the water demand. So that is why I'm saying the where the size is more, lower the surface area, so lower the water demand, so water cement ratio will be less. So that is why it was thinking before that higher the concrete aggregate size giving the more strength and the durability. But later it is discovered it's not like that, but it has the tendency when it's a lean concrete it give the better result, but it is a high concrete it's not give the better result. So I will come one by one. So that is why aggregate is important, and what is the properties of aggregate depending upon the size of the aggregate. Now, what is happening? The larger aggregate reduces the surface areas for bonding, leading to lower strength. They also make concrete more heterogeneous, causing uneven load distribution. So later it is discussed or that it is discovered that if the larger aggregate is the reduce the surface area, because lower the higher the size, lower the surface area, it for the bonding also and leading to lower strength, because it is required to bond the aggregate with the cement paste also. So if the bonding is less, that means the strength will be less, and they also make concrete more heterogeneous, causing uneven load distribution. So if the distribution is not proper, so there will be a heterogeneous concrete and causing uneven load distribution, which is the cause for the concrete failure. So this has the impact on the concrete surface. And again, the large aggregate can cause internal bleeding, weakening the transition zone with micro cracks and reducing compressive strength. So if the size of the aggregate is more, it can cause the internal bleeding and weakening the transition zone with micro cracks and reducing the compressive strength. That is why the higher size of aggregate is not using in the high concrete strength. It is only using in for the lean concrete. But reason is this. Now, if from this graph you can check, I'll show you two graphs. Now, the large aggregate reduces strength in rich, it is high strength concrete, but in lean mixes, their effect is minimal. In fact, larger aggregates give higher strength in lean mixes, while smaller aggregates perform better in rich mixes. So, this is if it is a lean mixes, then the higher aggregate is giving the best result. But it is the high mixes or the high strength, the lower aggregate gives you the better result. That is why we are always, if it is a high strength, giving the maximum size aggregate 20 or sometimes 10 also we are using. But if the lean concrete, we go for 80 and 40 is like that. So because of their capabilities and their properties, the size of aggregates also impacted the concrete strength or performance. Now here you can see two graph. You can check this graph also. You can get this graph also in the concrete technology books of by M.S. Shetty. I am taking from this from his books. It's a phenomenal books. You can read that one. Here you can see there is a get compressive strength and the maximum size of aggregate, and it is a cement content kg per cubic meter. So if my cement content is 170 kg, that is the lean mixes. See here you can say when the maximum size of aggregate is increasing, the strength is also increasing. But if it is 280, you can see here in maximum is coming is for a 40, and after that is become linear. And if it is 390 or something, here you can see after 420 it is going maximum, and after that it is going down. If the cement consumption is 390 kg per cubic meter, here it is in 20 mm, it is maximum strength. So if the cement content is more, it is not giving the strain whenever the size of the aggregate is increasing. It's only give the better performance when the cement content is 170 kg or lean mix or the less. Here you can see water cement ratio also. Here in the water cement ratio, here it is aggregate size and it is a compressive stage. So when is the water cement ratio 0.7, you can see it's giving the best result. It is giving the 10 mm maximum. After that, it's the linear one. But it's the water cement ratio 0.55. See, after the 20, it is going down whenever the aggregate size is increasing. And if it is the water cement ratio 0.4, it is also after 10, after 20, it is going down. So in the rich mix, we can conclude that if it is in the rich mix, the maximum size aggregate, whenever it is increasing, the strength is decreasing. If the maximum size is around 20, it is giving the best result. That is why the maximum size of aggregate is important in the concrete. So whenever you are selecting your concrete in the next time, check whether your cement content, whether it is water cement ratio, and accordingly you check the maximum size of aggregates. And I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your comment, so that from your comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.